x gets near, as x gets near a value, then it's the y coordinate. It's because it's the limit as x approaches c. It says so. It's the same. This is just better. No, but you will. I'll get it printed up for you. Okay, but it's still the same. It's still the same concept. I think I called it. So y gets near what we call the limit. Call it out. So it's the y coordinate. You're going to go close to something on the x-axis, and you're going to read off the corresponding y. We don't care what happens at c, though. Remember that. These are just the main limit theorems, and you already know it. But here's the deal with the main limit theorems. The limit of, if I don't like the way this is written. I mean, it's beautiful, but I'd rather see it a little simpler. Of f plus g is equal to the limit of f plus the limit of g. So you know that. I can distribute limits over addition, subtraction, multiplication, and even division. And don't forget that the limit of some constant times f of x is equal to the constant times the limit of f of x. Remember, we can pull constants out. Can't pull out x's. And even this one with the powers, let's just do this limit of f to the n. You can find the limit of the function and then raise that answer to the nth power. That's all okay. Now, the only time this is okay is if each limit exists. If each individual limit exists. Otherwise, you can't do it. So if you end up with one of these limits, like f or g, if they don't exist, then you cannot add their limits individually. You're going to have to actually do it this way. You're going to have to look at the limit of f plus g as x approaches c to the left, and you're going to have to look at the limit of f plus g as x approaches c to the right. And I don't know if you remember last year I said in BC Calc, we're now going to worry about the fact that the limits have to exist. And you're going to find out, g might not exist. It just may not exist at all. But when you look at the limit of the sum of these two things or the product, they may end up being equal, even though the individual limits for f and g are different, or don't exist. So that's your main limit theorem, and that's a big thing. So I've got a worksheet to help you work on that. And I give you the worksheet because it's important. Therefore, you need to know how to do it and be able to do it on the quiz. Then we have the one-sided and two-sided limits. This is to say that for the limit to be equal to L, that the limit from the right has to equal the limit from the left. And I meant to look up an AP question last year that has that. I'll bring it up, but I know you guys had to say this last year, that the limit from the right had to equal. You had to do that to get your points on the exam. Okay? Hey, you guys should be paying attention. Yeah. Now, here's something else I want to just hit on. Not much here. What this is saying, if you have a polynomial, and guess what? This is a polynomial. It's ax to the n, where n is a full number. Can't be a fraction, can't be a decimal, can't be a negative number, can't be any of those things. You now have a polynomial. And what this is saying is if you take the limit of a polynomial as x approaches c of f of x, because polynomials are clearly defined everywhere, they don't behave badly at all, you can just find the value of the function at c. Those are strings. If you remember it, I'll continue. So you don't have to look at the left and the right construction of polynomials. You certainly may do so. When in doubt, always look to the left and the right. You guys over there, this is all new for you. You must always look to the left and the right. But with a polynomial, if the theorem allows you not to. But if you don't know, then you better check from both sides. And if you have a ratio of polynomials, then you can just actually substitute c and n in that whole thing. But they have to be polynomials. Not true for absolute value, not true for greatest integer function. And a few others. It's true for... You're actually going to plug in values into your limit. But remember what you should always do. You should look for the 0 over 0. Okay. as x approaches 0 of absolute value of x is 0, we have to look at this from both sides. We have to look at our limit as x approaches 0 from the left. Do you guys not have this? Is this the pink one? Okay. What is, you guys, let's look at the graph. What is the absolute value function coming towards as x, guys, as x approaches 0 from the left, what's that value? 0. What's the value from the right? Because remember, this is absolute value. It's not a polynomial. I don't have a theorem about this one. What's this one going to be? 0. Since the limit from the left equals the limit from the right, it exists. And it's equal to 0. Now, the next one does not exist. And I want to prove that it does not exist. We've done this problem before. You might not have it on. Is that what it is? Okay. So now, I'm going to rewrite my absolute value function as a piecewise function. And yes, you have to know this because it's going to be on the exam. What's the equation of this line? Y equals x. So x, if x is greater than or equal to 0. Guys, what about the equation of this line? Negative of x if x is less than 0. Okay, now let's do this one. The absolute value. Let's look at it from the left. Let's look at it from the right. Let's do the right first because that's easier. Okay, what can I replace the absolute value of x with if I'm coming in from the right? Not 1. Absolute value of x from the right side, let me label this. This is the right, and this is the left, is just x. So you're right, that limit ends up being 1. Why can't I cancel those? 0 over 0 is not 1. Because you know what? We don't care what happens at 0. When we're really close to 0, I can reduce that. At 0, I can't do that. It's not allowed. That's why there's a hole in the graph there. What about the limit as x approaches 0 from the left? Whoops, not x. It's going to be the negative of x. So what's that going to reduce to? Negative 1. So what this graph looks like, if you put it on your calculator if you like, it looks like this. It's at 1, and it's at negative 1. So what's true about the limit at 0? It does not exist because, and you had to write this last year, I did not grade this one, but I assume that they were pretty picky. Yes, so we just did earlier today. I've done this several times. Like I said, this, and you guys should actually, get to know the AV students because you help each other. Because when you help them with this material, you actually learn it better for yourself. And this is the squeeze theorem. Now, and I don't think we talked about it last year, but if we have an open, it's called the sandwich theorem, so I pulled it out of the open because I learned my tongue first. Do that. And it says, as x approaches c, g is this pink one right here, and it has a limit of L. And H also has the same limit there. I don't care about what happens way away from the point, just find in that neighborhood. And then, what happens here for F? F is trapped between G and H. Well, what's got to be true about the limit of F there, no matter what happens? It has to be the same as L, doesn't it? What they call it the sandwich there, the sandwich in between. So how do you do a problem of that? How do you do a proof? Well, here's an example of one. I can't substitute in 0 because I get 0 times the sine of 1 over x. Do you remember what happened with the sine of 1 over x? We're not going to get that worksheet today, but that's okay. Let's look at it because I want to show you too what the Inspire will do because it's a much nicer picture. And we'll start off our class on Monday with that worksheet. Two fours. And I will what we're doing when we've got things figured out. I mean, I got things figured out. They just have to put together. You can't. That's exactly my point. You can't do the limit of x squared times the limit of the sine of 1 over x because the limit of the sine of 1 over x does not exist. Okay, David? I'm going to type this in. I'm in radian mode. Trig sine of 1 divided by x. Okay, there it is. And when I do this, I can get not just a thick graph. So I'm going to zoom in, like window zoom. I'm just going to zoom in on it because this is going to the center here. And then let's keep pressing plus. Yeah, what is it? Too many wiggles. Remember this one now? Okay? So that's the problem with that. So this is too many wiggles. So what is 0 times does not exist mean? That's the problem. So what we're going to do is we're going to take this function here and we're going to rewrite it. We're going to, well, actually, we're going to trap it. The sine of 1 over x is always between what two values? I don't care that there's too many rules. What's the maximum y value? 1 and negative 1. Now, so I can trap it between two things. And I am now going to multiply by x squared because I want it to look like that. So if I multiply this by x squared, this by x squared, and this by x squared, and I take the limit of all three parts, guys, you're not going to know how to do homework. Unless you want to come back tonight and watch the video again, which is crazy. Why would you do that? The limit as x goes to 0. What's true about this limit as x goes to 0? What's the limit of 0 squared? What is it? It's 0. I don't know the middle one. This is a BC topic. And what's the limit of x squared as x goes to 0? 0. Since these are both 0, and it's clear that this is between those because I started with the sine of x between 1 and negative 1, what has to be true about this limit? It has to be 0. You just say by the squeeze theorem. You have to give me a reason. And there's the picture. You can see how it's, even though it's too many wiggles in there, still be pushed in between those two curves. So, this is kind of cool. Now let's just review limits briefly. What should you always do first when finding a limit? Substitute. Always. Always substitute. And then, one of four things will happen. You'll get a number divided by a number, which is actually quite boring. That's just equal to L. So that doesn't do any work. I get 0 divided by a number. Yeah, but remember, you always have to substitute. And if you don't show the 0 divided by the number or the 0 over 0, you will not get the rest of the point. That's 0. I can do this one, a number divided by 0. Emily, what's that going to give me? What's this going to give me? Not 0. Undefined. Actually, it's going to be plus or minus infinity, so you know that. And the last thing is 0 over 0. And that's the one, I don't know what it is. It's indeterminate. Some of you say that 0 divided by any number is 0. Some of you are going to say, well, 0 over 0 is 1 because it's the same number. 0 is a special number. And some of you are going to say, when you divide by 0, it's undefined. So I have three answers, all of which are wrong. Can't do any of those. This is going to be, if you're talking about rational functions, it's going to be a whole. You're going to have common factors. So you have to do some work. Guys, why are you here? You have to do some work. Now, Mrs. Hersman says, don't stop. That's right. Don't stop believing. Don't stop. Whatever makes you remember that when you get 0 over 0, you have a lot of work to do. Yeah. And you need to do the the homework. We need to do those problems. And so we'll stop here. I won't even give you the worksheet today because we'll get there. But they should be working on the homework, and you may have questions on Monday. See, I'll give you the question. Oh yeah, we have. You can if you want, but we're going to do it on Monday class. So if you want it now, you certainly may do that. I just ran out of time going over the test, which is why I always want to go do the lesson first.